My name is David Ada Ogale from Federal University of Technology, Minna, Niger State, Nigeria, School of Architecture, Department of Architecture. My paper is on operational energy management in tropical public buildings. We focus on integrating passive design, technology, and policy in Abuja, Nigeria. Background to the study. Energy efficiency in building has become a significant global problem as energy demand rises, operational costs rise, and the effects of climate change worsen. Energy, being a scarce and precious resources, require efficient management to avoid waste and assure long-term use. Operational energy in public office building is a significant challenge to sustainability in tropical emerging nations, where energy supply deficiency, growing costs, and climate change concerns all interact. In Nigeria, government office buildings rely heavily on mechanical cooling system and backup generator, resulting in excessive energy consumption, energy inefficiency, and high greenhouse gas emission. Problem statement. Although the Nigerian government, through the Federal Ministry of Power, Works and Housing, in collaboration with the Nigeria Energy Support Program, introduced the Building Energy Efficiency Guideline in 2016. In application is largely limited to new building and offers little guide for managing energy use in existing public building. These gaps highlight the need for a context-sensitive operational energy management framework that incorporates design technology solution, and regulatory tool adapted to Nigeria's socio-economic climate condition. The aim of the study. The study is aimed to create an operational energy management framework for public office building in Abuja, Nigeria. And the objective are as follows. One is to identify the factors influencing operational energy consumption. Secondly, to assess current design practices in public office building in Abuja, Nigeria. Third is to investigate energy sources in public office building. Then fourth is to determine options and constraints to controlling operational energy consumption. Then fifth is to synthesize these findings in a practical and applicable framework for effective operational energy management in public office building. And in the course of this study, literatures were assessed, and studies show that the office building wastes up to 30% of their energy due to inefficient systems, poor management, inadequate design integration, passive design solutions such as building orientation, natural ventilation, daylighting, roof design, and material selection are crucial for regulating internal temperature and reducing energy consumption. Some gaps were also observed in the literature, and the gaps were as follows. As despite the established efficient measure, passive techniques are frequently used inconsistently in poor countries due to inadequate regulatory enforcement and practitioners' understanding. And the second is Nigeria lacks a comprehensive operational energy management framework for public office building, indicating a serious concern of policy needs. The research design and approach. This study used a quantitative cross-sectional research approach to analyze operational energy management in public office building in Abuja, Nigeria. The approach was chosen to allow for a systematic examination of professional perspectives, users' behavior, and priorities regarding operational energy use, as well as to facilitate statistical reduction and structuring of many energy-related design variables. The study uses the relative importance index and the principal component analysis to prioritize and reduce the dimensionality of operational energy management. The study area and data collection instrument. The study area was conducted in Abuja, Nigeria's capital, with hot tropical environment, high solar radiation, and fast-rising public building stock. Residents were drawn from building professionals directly involved in the design, construction, and operation of public office buildings, such as architects, engineers, facility managers, and energy consultants. Primary data were acquired using a structured questionnaire based on thorough assessment of building energy efficiency. The questionnaires contained 5 sections that corresponded to the study's objective. Respondents were gathered using a 5-point Likert scale, ordinal data appropriation for relative importance index calculation, and multivariate analysis. Data analysis. The relative importance index was used to prioritize elements influencing operational energy use, designers' techniques, and energy sources. The relative importance index value ranged from 0 to 1, while the principal component analysis was used to condense the 16 identified building, design, and operational variables into a smaller set of interpretable components. Two standard tests were used to assess the data set appropriateness for the PCA. One is the Kaiser-Meyer-Hopkins, while the other is the Bartlett sphericity test. Although the KMO value is 0.38, is lower than the traditional threshold of the 0.5. But since the Bartlett test of sphericity was statistically significant, showing the sufficient correlation of variables, it was necessary to be adopted. The result. The vast majority of the respondents are members of recognized professional organizations, such as the members of Nigeria Society of Engineers, which were rated 60%, the members of the Nigeria Institute of Architects, 20%, and members of the Nigeria Institute of Quantity Surveyors, which implies adherence to professional standard, ethical values, and ongoing professional development, adding credibility to the respondent assessment of energy management method and policies. While present professional practice in Abuja strongly advocate for passive and low-cost technique, the limited impact of energy specialist discipline shows that policy-led framework are required to bridge the gap between design intent and long-term operational energy performance. The findings and discussion. The findings demonstrate that design importance does not always convert into implementation without enabling governmental and institutional support. Smart building technology and automation were a unique PCA compound, but had the lowest relative importance index and adoption level. Although the global literature identifies automation as critical energy efficiency, Nigerian public buildings confront maintenance and skill issues that limit their efficacy. This support a staged adoption in which a core passive tactics comes before sophisticated technologies. The diagram is an indicative proposed integrated operational energy management framework for optimizing public office building in Abuja, Nigeria, where the sources of energy consumption, which is electricity, which serves as the main grid, and the diesel generator and the solar grid, they all are identified as sources of energy while the method of adoption captured within the column at the middle, and the result of this adoption, where how energy is reduced, energy consumption is reduced, and with operational resilience and all the results that. Policy implication. First is to Abuja Development Authority, is to integrate passive design mandates in development control, establish minimum envelope and HVAC performance standard, establish energy management at the building level, a phased retrofit strategy for existing public building, because many public buildings in Abuja are already up. And the second implication, when it gets to power, the Ministry of Power, is to move policy focus on supply expansion to demand management, implement building level energy management system, and third, to promote renewable energy integration incentive and financing, and capacity development and technical training. Finally, overall, the study advanced knowledge by proposing a context-sensitive empirical paradigm for operational energy management in tropical public building. It reveals that effective energy reduction in Abuja public office building requires prioritizing passive design, enhancing envelope system integration, and facilitating a phased transition to advanced technology through supportive policy and international and institutional processes. Those are references used. Thank you for listening. I hope knowledge has been transferred. Thank you very much.